Hi, I'm Patty. I'm going to lead you through this unit orientation video for the fifth grade unit, Ecosystem Restoration. In ecosystem restoration, students take on the role of ecologists working for Natural Resources Rescue, a group that works to protect and save fragile ecosystems around the world. Students learn that they have a project report from Natural Resources Rescue about a problem in part of the Costa Rican rainforest ecosystem. A portion of the ecosystem is failing. Many years ago, trees were cut down and the land was dedicated to cattle grazing. Since then, the cattle have left and trees were replanted on the land. However, the organisms in this area of the rainforest, jaguars, sloths, and cecropia trees, don't appear to be numerous or very healthy. Students will work to understand how to restore the ecosystem, and they will explore what it means to grow and how living things get the matter and energy they need to grow. As students work through the 3 chapters, they gather evidence from multiple sources by doing, talking, reading, writing, and visualizing. Their explanations become more complex over time as they construct understanding about ecosystems and figure out the clear links between decomposers, nutrients, and plant growth to come up with an explanation for the unhealthy restoration area. This unit is an argumentation unit. In their role of ecologists, students engage in oral and written scientific argumentation about the source of the problem in the failing ecosystem. They have an opportunity to write and revise a rainforest restoration plan in which they explain in their own words why the ecosystem is failing and support arguments by using evidence. By the end of the unit, students present their final restoration plans, including a recommended course of action to restore the failing rainforest ecosystem to its original condition. The focal cross-cutting concept emphasized in the ecosystem restoration unit is energy and matter. In their role as ecologists, students gain an understanding of the necessary and limiting role that energy and matter flows play in a system. As students investigate a failing ecosystem, they develop an understanding of plants and animals' need for matter in the form of food molecules. Through participating in argumentation to explain why the organisms in the ecosystem are not growing and thriving, students trace matter back from animals to plants to water and carbon dioxide, and they trace the energy that all living things need back to the sun. Students also find that while plants bring matter into the ecosystem, nutrients released by decomposers are also critical for plant growth. Students return to the idea of energy and matter again and again throughout the unit through a variety of modalities. There are also opportunities to emphasize the cross-cutting concepts of systems and system models as students look at the inputs of air and water molecules and of energy to the system that is defined by the organisms of the ecosystem, and scale, proportion, and quantity as students build on their understanding of matter and substances mixing to form new substances. Every Amplify Science elementary unit also includes focal sense-making strategies, which students leverage as they read and also during investigations. This unit's sense-making strategies are making inferences and synthesizing. The main writing genre in this unit is scientific argumentation. Well, that's the overview. So now I'll talk you through what happens throughout the unit, how students build from their prior knowledge to get to a complex causal explanation of the anchor phenomenon. To do this, I'll summarize the key ideas students figure out in each chapter and how they use these ideas to explain the anchor phenomenon piece by piece. For each chapter, I'll highlight 1 or 2 key evidence sources students will use. But remember, in every chapter and every lesson, students gather evidence multimodally from many different sources. In Chapter 1, students collect evidence to answer the question, why aren't the jaguars and sloths growing and thriving? They will investigate and learn that the food matter that animals need to grow and use for energy can always be traced back to plants. Key evidence sources in this chapter include investigating how animals use food molecules in the sim. Students then synthesize information from the sim and text, discuss and make a scientific argument as a class about how animals grow. At the end of chapter 1, students return to the anchor phenomenon. They explain that jaguars eat the body matter of sloths as food so they can grow. They change the food molecules from the sloth into molecules that build their body matter or release energy for movement and growth. The sloths eat the body matter of cecropia trees as food so they can grow, and they change the food molecules from the cecropia trees into molecules that build their body matter or release energy for movement and growth. Because there aren't enough cecropia trees in the failing rainforest ecosystem, the sloths and jaguars did not have enough food. In chapter 2, students work to find out, why aren't the cecropia trees growing and thriving? They find out that energy from the sun is brought into an ecosystem when plants make food by using water molecules, carbon dioxide from the air, and energy from the sun. In this chapter, students read, "Energy makes it all go," and they synthesize information from the text and the sim. Then they engage in the leaves and roots game and use the ecosystem modeling tool to show their understanding of where plants get their food. At the end of chapter 2, students explain that cecropia trees in the rainforest ecosystem make their own food. Like all plants, they use energy from the sun to turn carbon dioxide and water into food molecules. They change these food molecules into molecules that build their bodies or release energy. The cecropia trees must not be getting the sunlight, water molecules, or air molecules that they need to grow and thrive. In chapter 3, your class will try to answer the question, why aren't the cecropia trees growing and thriving in the soil? Students investigate and find out that decomposers consume dead matter and release nutrients that plants use to help them make food molecules. Key experiences that help students understand these ideas include analyzing data from the project area and then discussing the role of nutrients in the ecosystem. Students will also read again from restoration case studies and critique a scientific argument about soil. At the end of chapter 3, students are able to explain that decomposers live in the soil in the rainforest ecosystem and use matter from dead organisms as food. Decomposers change the food molecules into molecules that build their own body matter or release energy for movement and growth. And decomposers also release nutrients into the soil. Nutrients in the soil are important for cecropia trees because they help the plants make food and body matter. Because there are not enough decomposers in the soil, there are not enough nutrients. This is the reason the cecropia trees are not thriving. Well, I hope you're feeling excited to start on this unit. In addition to the resources on the Amplify platform, check out the at-home videos and at-home unit to help you teach this unit this spring. You can use any combination of these resources to engage your students in figuring out about ecosystem restoration. Please let me know how I can help you plan for instruction. I'm Patty Works, and my email address is pworks@amplify.com. Thank you.